My name is Stoltman, and I will be talking to you about Kotlin Multiplatform. I'm Android developer for a long time, and I am Kotlin Multiplatform developer for quite a few months now. And this talk will be about the difference between Kotlin Multiplatform and other cross-platform frameworks like Flutter or React Native. It will be trying to convince you why Kotlin is the good choice and why Kotlin Multiplatform makes sense, and whether it's ready for production or not, because I don't know if you have heard, but it's still experimental, so there are some doubts. Okay, so first of all, I would like to explain to you what are the cross-platform frameworks. I think that everybody in this room knows the most famous ones, like Flutter, PWA, React Native, and Xamarin. And you guys, I think you guys know what cross-platform is all about. It's about writing one code and creating few apps from it, like basically in short version. It's a great solution if you want to downsize your team and you don't want to write the same thing twice, because it doesn't make that much sense. But there are some disadvantages to this approach, and I will first explain the disadvantages. The first big disadvantage of shared cross-platform frameworks is surprisingly the shared UI. Because shared UI is super hard to make correctly. If you want to share UI, you either end up with something that's either inefficient or it doesn't have all the little quirks and differences and all the nuances of platform-specific UI. So it's hard to do. It's never as good as the native platform UI. So Flutter is great, Flutter is awesome, but if you want to write an app in Flutter, it's never as good as the native UI. If you use cross-platform framework, you have to commit to one framework. So if you start writing something in React Native, you have to finish this app in React Native. Like, you cannot decide halfway through this, to writing this application that you don't want to use the React Native anymore and you want to just throw it away and use Flutter. You have to commit it, and you have to find someone who knows how to use it. So you have to look for developers. And you never know whether this framework will still be here in 5 or 10 years. And it's huge risk to write a very big application in something that may disappear soon. And with almost the same concept, there is commitment to one language. It's especially important in Flutter's case, where commitment to Dart it's tough. Like, Dart isn't that popular, it's quite new, so finding someone who is very specialized in Dart, has a great knowledge about Dart, is hard. It's even harder than finding a good iOS developer in Warsaw. And those frameworks have quite a limited application. Like, you cannot really write everything in those frameworks. If you use Flutter, you cannot write backend in Flutter. You can write backend in Dart, but then you would have to copy and paste this code to Flutter and compile it again, or you would have to create another library and then provide this library for your Flutter app and for your backend if you want to share something between backend and Flutter app, mobile apps. And with this in mind, there is a question, there is also overhead for all those frameworks. Like, most of the time you have some kind of virtual machine or some kind of a bridge between your native platform and your cross-platform framework. So it's never as efficient as native mobile apps, or it may just result in a bigger size of your application, of your APK or APA. So with this in mind, there is a question whether we really need something like Kotlin Multiplatform, whether we need another cross-platform framework. Because, well, we have these ones and they are mature, quite mature, and they are not so new, so it's easy to find developers, and yeah, they work. So why would we need another one? And the real answer to this is that we really don't need another one. We have this, what we have, and it's great, we can use it. But Kotlin Multiplatform is not at all about sharing UI. It's not about being cross-platform framework. And this is one of the most important points of the talk, that Kotlin Multiplatform is not the same as Flutter. They are not rivals. They are not in each other's faces. They are not rivals. It's completely different. And let's start with Kotlin itself, because big part of Kotlin Multiplatform is obviously Kotlin. And I said that commitment to one language is the wrong thing, so why would we want to commit to Kotlin? Because, well, it's also new. You have to commit to Kotlin, but I'm quite convinced that Kotlin is one of those languages that are here to stay, and it's one of those languages that are quite good, actually. Some reasons for my talk. Kotlin is crazy popular right now. Since its release, since the 1.0 version, it's skyrocketing. It's getting so much traction. It's just crazy. This is the GitHub popularity in 2018, I guess. It's open source, so if you happen to find any bug, you can just go and fix it yourself, in theory. If you are a security freak or performance freak, you can always just go there and check out how it works, how they implement things. So that's good. It's supported by major players, so it's here to stay. Intelij IDEA is supporting it very hard. They are committed to supporting it for the next at least 10 years, and they are hoping that this will be the Kotlin will be the reason people will start buying more enterprise editions of Intelij IDEA and stuff like that. So it's their business model. They are not going to put it to waste. And Google for some time right now with supporting Kotlin for Android development, obviously. They made it an official language, and that's why it's crazy popular. And Gradle, kind of. Like, Gradle is migrating to Kotlin from Groovy. It's not there yet. The Kotlin plugin for Gradle is still kind of slow, but they are working on it. And it's very similar to both Java and Swift. And this is important because, in contrary to Dart, it's very easy for Java developers and Swift developers to migrate from their languages to Kotlin. In my team, it took our iOS developers like a month or two to really get comfortable with Kotlin. Maybe they are not great experts right now, but it's easy, it's doable. It's not as hard as going from Java to C++, for example. And it's modern. So it's young. The JetBrains team are looking into the future. They are not really hanging on to old habits and or paradigms. The generic system of Kotlin is here to stay and support the future problems, solve the future problems. And community is quite helpful. Like, there are Kotlin cones, which is JetBrains thing for new developers in Kotlin to help them in studying Kotlin. It's a set of exercises that you can solve online, and you can just write code online and compile it and study all the crazy things. And if they release coroutines or something like that, you can go there and they have all those edge cases and small little things that you wouldn't normally know. It's super helpful. There is Kotlin Lang Slack that I couldn't recommend enough. There are some great people there. There's Jake Wharton there. And they are all super helpful. Kotlin is still at the state where all people that use it are super excited about its development. So if you go there, you will not be faced with judgment that you don't know something. User groups, again, thanks to JetBrains. JetBrains is trying to have user group, so a group of people interested in Kotlin making meetups in every major city all over the world. So if you are going for a holiday to somewhere, anywhere, you can always go to JetBrains' site and check out whether there is a user group there and maybe meet up with them. And there is Kotlin.link, which is a library of Kotlin-related frameworks, IDEs, libraries itself, and stuff like that, that you can just go on and find anything you may use and you may find helpful. With this in mind, I would like to actually start talking about Kotlin Multiplatform, not the Kotlin. And there is this definition of Kotlin Multiplatform. It's quite good. It's very compacted, and it's made by Kevin Galligan, who is one of the most active community members about Kotlin Multiplatform. He's not a part of JetBrains team, but he made so much for Kotlin Multiplatform. And this is his definition of what Kotlin Multiplatform really is. And I will go by this definition point by point. So first of all, this is important, that Kotlin Multiplatform is optional. If you start using Kotlin Multiplatform at any point in time, you can just pull it out of your apps, pull it out of your project, and it shouldn't be too hard to replace it with something else. As if you use React Native, you have to rewrite everything from scratch. If you use Kotlin Multiplatform, you can treat it as plugins, as kind of libraries for your app, for your project. So you can write as much or as little as you want in Kotlin Multiplatform and then just pull it out or add more if you like it. It's natively integrated, so there is no overhead, completely no overhead. If you have your Android application, it sees Kotlin Multiplatform part as either part of your project, because it's also JVM, so you can just put it as another package in your project, or just another AAR library. It's the same with iOS and Mac and Linux and Windows, where they see it as native binaries. And in JS, JS sees it as just another JS bundle. It's open source, again, the same thing as with Kotlin. You can just go on and check it out and check how it works. And it's up for code sharing. So the point of Kotlin Multiplatform is to share logic. It's not to share UI. Because sharing UI, as I mentioned, is super hard to do correctly. But sharing logic is quite easy, actually. Like Java did it, so why couldn't Kotlin Multiplatform do it with JVM? So Kotlin Multiplatform, in this case, is all about sharing the business logic, not the specific implementation on how something works. And it doesn't facilitate shared UI, for now at least. Maybe in some future, once the Android Compose and SwiftUI are ready, maybe then, but not for now. And Kotlin Multiplatform, as I said, supports different platforms, like systems. So there is JVM with bytecode. This common Kotlin code gets compiled down to bytecode, and it runs on JVM as a native library of sorts. There is JS, where Kotlin gets transpiled to JS code. And there is any native platform where Kotlin is seen as just binaries. So anything that has processor can just go and run Kotlin. And how does it actually work? This is the meat of the presentation. So at the very bottom, there is this common code, which is just plain Kotlin code. There is no platform-specific APIs, so if you want to have any file AO, if you want to know whether you are on the main thread or not, or any other thing that you need very specific information about where you are running your code on, you don't have it. You cannot access these informations. So you have this common code, and if you want to access something very specific about your platform, like whether you are running on the main thread, because this will be different whether you are on the iOS or Android or JS. So if you want to access information like this, you have to somehow get it out of thin air. And that's where the expect and actual mechanisms come into play. Expect and actual mechanisms can be explained as interfaces of sorts, where common code defines that it expects some information, some class, for example, or some variable to be available, and platform-specific implementations have to provide this expected implementation with the actual keyword. So going back to our main thread, example. Let's say that our common code expects a value which says whether we are on the main thread or not. So on the JVM specific code, we would implement this like that. I will expect in a second how this JVM specific code knows about main loopers and loopers in general, main looper. iOS would expect it like that, it would implement it like that, and on JS it's always true, because JS. So basically, everything you need from platform is realized like that. You expect something, and you get actual. Whereas this red square with k/n is Kotlin native. And Kotlin native is a part of 3 smaller frameworks that are the essential part of Kotlin Multiplatform. This is pretty much all of the Kotlin Multiplatform. This is all the thing you would ever need to know about Kotlin Multiplatform, unless you want to dig into details. There is common code, which is platform independent, as I said again. There is Kotlin JVM, which is just plain old Kotlin. You have access to JVM APIs there. It's a framework which allows you to interact with JVM. There's Kotlin native, which allows you to interact with native platforms. And KJS, which is responsible for transpiling the common code to JS. So if it works like that, you can always write your common code in common code, then use the actual implementations, and thanks to some magic that I will explain in a bit, you can end up with something like that. And all of those 3 artifacts at the end contain the same logic with different implementation of some details. So that's awesome. You don't have to write the same thing thrice. And then you just put those artifacts in your applications and they just run. Whereas this one is optional, you have to remember. It can look like that, but you also should know that you can split common code into multiple layers, let's say. So if you want to share some data models between your application and your backend, you can always write your data models in plain Kotlin, then share those between common app code, which will be shared logic between the mobile applications, and common backend, which will have just the backend logic in case you want to switch from Spring to, let's say, Ktor. And you can do any configuration you really want. If you have, let's say, Android TV on the left side, then you can create another common package with just the common logic code for Android. It's the same with iOS and tvOS, or if you want to support some multiple different native platforms, like on Linux and Windows you want to have the same logic, but let's say on macOS you have to get something different. Then you can just split it as much as you want. There is also an alternative. I didn't use it, almost nobody uses it, but you can write all of your code in Kotlin native, like interacting with the processor, and then just put binaries out there and use those binaries everywhere. It's possible, it's fast if you manage to pull it off, and it's super cumbersome to write because let's imagine that you have to write your Android app in C++ or something like that. Not cool at all. Okay, so that's basically the Kotlin Multiplatform. If you ever have to know anything about it, it's that it should look like this. This is your project, this is your package structure. And the cool thing about this is that if you have the framework platforms, the front-end platforms, you can also split the logic as much as you want. So you can just have some API communication in your common code using Ktor as a client, or you can have as much as presenters. Like my team and I, we use MVP and we only implement views on platforms. So writing the platform-specific code is very simple. You just implement the interfaces for views, and the presenters on the command side take care of everything else. And talking a little bit more about the sources, like those layers I mentioned, targets, so let's say JVMs and native platforms, and compilations, which I will explain in a second. First of all, source-it. Source-it is, as I said multiple times in this presentation, is just a file with Kotlin code, any file, any Kotlin code. It doesn't know anything about the platform. It may have some platform-specific libraries, it may interact with the platform, but it's still just Kotlin code. Target is a part of build, responsible for building, etc., etc. So this is pretty much just your JVM, let's say. If you want to use JVM, then it's JVM. If you want to use macOS, then macOS would be your target. And supported target platforms are as such. So you can run your Kotlin native code and your Kotlin code pretty much anywhere where it matters. Like you can run it on PS4, like there are some crazy people who do this. Yeah. And compilation is like if you want to have one JVM target and you want to put out few jar files with different logic, you can use different compilations for different purposes. Boring stuff. And as in the end, it kind of looks like this. You have the layered common code at the bottom, then more specific code as it goes up, and every source has its code source test code source set. So if you have common code, you can have common tests, and you can run them on all the platforms. So you just split your code nicely into packages. Okay, and in case of JVM, it looks like this. Just common code with expect, more specific code with actual, and very specific compilation and target, which creates classes, then creates jars. And it's all configured with Gradle. And those Gradle scripts can get quite complicated. And you have to really know what you are doing, or just copy-paste everything from internet, hope it works. And I will not go into Gradle that much on this presentation because I don't have time, nerves. But there is one piece of advice I can give you. It's to use the Gradle Kotlin script plugin. Yes, it's slower, it takes a little bit longer to build and compile, but it's so helpful with the auto-completion, and all the great examples out there are in the Kotlin script Gradle, not in Ruby. There's also one topic I would like to mention, because if someone heard about Kotlin Multiplatform like 4 months ago or 5 months ago, he would be terrified with how little tooling support there is. You would go out there and you have to write everything from scratch yourself. Like there were Gradle plugins, but there was no tooling for it. It was terrible. But 4 months ago, with the newest release of Intelij IDEA, there is something like that. So if you want to write a library, you just take a ready-made template. If you want to write mobile iOS, Android, you have template for that. And in case of multi-platform library, it would give you something like this, where you see the common code and more specific platform codes as just Kotlin packages in your project. And it also generates your Gradle file, like this. This is the simplest Gradle file you can get in Kotlin Multiplatform, and it will actually run. It defines some, going from the top, it defines some targets, then some compilations and sources. Easy peasy. Okay, and it's quite easy to use Kotlin Multiplatform on JVM because it's obvious, it's just Kotlin. I have no idea about Kotlin.js. I just use it a few times to check whether it works, and it does, surprisingly, but I'm no expert in Kotlin.js. But when it comes to Kotlin native, there are some huge pitfalls that you have to watch out for. Like there is one, but it's very, very huge, and you have to be very careful while using Kotlin native. And this pitfall is state management. State management is completely different in Kotlin native than it is in the pure old JVM. You have to be careful because the object state belongs to only one and only one thread. So you cannot just go around passing objects on the left and right and hoping that it will work, because it will not. If you want to share state, it has to be frozen. I will explain frozen in a little bit. And there is no manual concurrency management. So there is no synchronize, there is no volatile, you cannot do it on your own. You cannot just go there and manage threads on your own. Like, you can, but it's hard and you are not supposed to. On iOS you can do some crazy stuff with it, but it's more of a hack, an actual solution for a problem. And Kotlin native, every time you try to mutate some state, like you want to add some integers together and assign them to a variable, it verifies whether you can do it. And if the object was frozen, then there is a flag at its CPP header, like frozen. And you cannot mutate this object, basically. You cannot change any references in it. And when it comes to object freezing, there are some rules you have to remember about. Like, every object can be frozen. Singleton objects have to be frozen. If object is frozen, everything in its references also gets frozen. This is annoying because if you have a very big object which holds many references, then you actually freeze like half of your application. You have to be super careful. And for example, if you have a big hash map as your in-memory cache and you freeze it, then everything gets frozen and you cannot add anything to this hash map, and you cannot delete anything from the hash map. So this is crazy. And objects cannot be unfrozen. When it's frozen, it's frozen. You cannot take this flag down. And frozen objects cannot be mutated, obviously. I cannot see what I'm doing because it's stuck on my screen. And for example, if we want to pass an index to our Lambda and freeze it, and then pass it to run in background, we would do it like that, but this would actually break. This would actually fail because it gets frozen. You cannot mutate it. Global variables can only be accessed from the main thread. If you want to access them from another thread, it will fail unless they are annotated. And there are two annotations about this. There is thread local and thread immutable, whereas thread local says that, oh, if this global variable if you try to access this global variable from a background thread, it will make a local copy of this variable. And there is thread immutable, which just freezes the global variable and posts it to all other threads. And as surprisingly as it may sound, it's okay most of the time. Like, this freezing is not much of a deal because most of the time you don't want your state to change. Like, changing data models is bad practice, so you would much rather want to create this object again with new information in it. So it's a little bit like functional programming. Like when you have in-memory hash map cache, then it's bad. There are some workarounds. You can use atomics. You can just recreate everything every time you pass it. But actually, atomics are expensive when it comes to memory because they don't get cleaned up that fast. Recreating everything every time it gets frozen is also expensive. And freezing is expensive because it has to go through the whole subgraph of references from this object. There is a thing called detached object graph as well. I will just mention it. It allows you to pass something to another thread if you are able to detach the whole graph from your main thread. So if nothing references this object and it can reference something else, but nothing else can reference this thing, then you can. So, like, this would work. You could then detach this graph and pass it to some other background thread, and this background thread could mutate this presentation object inside, that would be okay. But this would fail. This would fail hard. And this would also fail. You cannot have any reference from the outset. Because no. And Stately is the Kotlin Multiplatform library for freezing and atomic. I would recommend it because it's great. Yeah. Do you want to say anything else about freezing? I hope not. And the big question whether Kotlin Multiplatform, with all you've seen, is actually ready to go. And the answer is that it's still experimental. Like, it's new. It's still in beta, pre-release, experimental state. There are so many things changing, but the API is actually stable. The JetBrains said that they will not change anything important anymore at the very basis. So yeah, it's ready for production. Like, there are some applications running in conferences that are made based on Kotlin Multiplatform. My team and I are working on a huge production-grade application written in it, and it works, surprisingly. So yeah, now it's the great time to start, actually, because like from the technical point of view, it's great time to start, because you can be an expert in this, you can give tech talks, and everybody will listen to you, and you're like, yeah, I used it when it was experimental. There are still some things missing, like important stuff. Multi-threading coroutines is a big no-no. It's not supported on Kotlin native. There are ways to work around this, but multi-threading is still problematic. So yeah, it's not really great. We use multi-threading coroutines for parsing big JSON objects, and it works. It doesn't freeze the UI, so that's a plus, but it's not a pleasure in any way. There is no good date library. There's one library, but there are some controversies around it because it doesn't have time zones, basically. And so if you need some date, you have to roll out your own library based on the platform-specific APIs. There is no proper tutorial, so if you want to, there is a big set of rules given from JetBrains. There is one long post from JetBrains. There is a lot of stuff from Kevin Galligan. There are some examples, but there is no proper tutorial that will lead you step by step through all the things you have to know. And so it's a little bit of a jungle out there. There is no Kotlin native mocking library, so tests on iOS are a little bit harder. The plus is that you don't really have to, you should test your common code, but you can unit test it on JVM. So you don't really need the mocking that much. You just have to write some integration tests or UI tests with mocked database and API connection, but you can do it on your own. And that's actually the hard part. It will not be released anytime soon, I guess. It's a big problem. And there are no reactive libraries. If you're used to coroutines, it's not a problem, because coroutines, you have flows. But if you want to use something like Eric's Java or X Kotlin, nope, no way. And now I will give my spot here for a few minutes to a friend of mine, Maciej, who will talk about more business side of Kotlin Multiplatform. In my opinion, like from a techie guy, starting this project in Kotlin Multiplatform is a great way, is okay. But maybe there are some business people out here who would also like to see whether it's worth it or not.
Yeah, thank you, Jan. So I'm Maciej Różański. I work with Jan and guys on this multi-platform project at Proexe, and I work more as tech lead. So I will try to show you or maybe explain if it's good to start a project, Kotlin multi-platform project right now, because maybe it's not a good idea, maybe we have some problems and so on. So, okay, so this is typically like common scenario for our projects. We have two platforms, Android and iOS, and we have different approaches how to solve this, how to create this project. So basically, we can create native application. So there's a problem because if we have a lot of business logic, we have duplicated work like on Android and on the iOS side. But common solution is to create some CPP module and share some tricky parts like algorithms and so on, and use some binaries on both sides. Second solution is to use some multi-platform framework, like Jan said. We have, for example, great frameworks like React Native or Flutter. But there are some pitfalls because, for example, if you are a software house and you are creating native Android and iOS application, you need to find new developers with different skill set and which are familiar with React Native or Flutter. So you need to find new people to create the project, and maybe this is not a good solution. And we have a third option. This is Kotlin Multiplatform, where we can share logic, business logic, and create UIs for different platforms. Yeah, one big problem with Kotlin Multiplatform that this is still experimental and you can feel it. I mean, probably if you want to write project for Android and iOS, it will take more time to create one Kotlin Multiplatform project than creating separated apps for Android and iOS with like mid developers. But we can have like more interesting situation like this. So, for example, we're creating project not only for 2 platforms but for 4 platforms. We want to add application for TVs. So, common solution is to create some common code for Android platform and common code for Apple platform. So we have 2 libraries. We duplicate business logic only once. We can also use React Native and Flutter because they have some kind of support for TV application, but have some problems. Like, for example, don't support leanback, but we want to use leanback for Android TV, and there are some problems with focusing, with using remote control. To complicate a bit, because we have such situation, we want to add few more platforms to implement. So, for example, we want to create smart TV application for Tizen and for LG WebOS, and the same story. We can share some module, some JS module for this smart TV application. But we can go deeper. For example, we have not only smart TV application, but we need to create also Android TV box with custom launcher. So we have like another platform, which of course we can merge with Android and Android TV application, but maybe this is not solution. And for example, we want to create web frontend. And for example, we creating like VOD platform, so we want to create also application for PlayStation 4. But fun fact is that this is actually our case. So we not only create like 9 or 8 platforms, but we also implement, we create different implementation of our product for different clients. So we have many different projects with different UIs where we can share like common business logic. and we have so much different platforms. So as you can see, we have like this big matrix of different applications we need to create. Each one has a little bit different UI because we want to create native views for each platform, and different implementation, different project is also have different UI because all the clients want to have like UI creating for them, and most of the business logic is common. So in our case, solution is to have Kotlin Multiplatform common module, because in our project we have a lot of business logic shared. For example, we connect the same APIs. We check the same conditions. We process input from users the same way. Only thing is that, first of all, we want to support many platforms, and second of all, we want to create different UIs for different clients. So, conclusion. First of all, you need to think about that Kotlin Multiplatform is still experimental, and you probably will cost of production of application for two platforms will be higher using Kotlin Multiplatform than just writing native application or using Flutter or React Native. But for us, after this experience with first project, probably we will start some of next projects using Kotlin Multiplatform framework, because we know all the pitfalls and problems. If you're creating a project that is dedicated to many platforms, like our project, you should consider using Kotlin Multiplatform as we do, because we don't see many problems, and we see a chance that it will work well on all these platforms. If you are afraid to start new project like from the scratch in Kotlin Multiplatform, you can try to replace some small common module, for example, some algorithms and so on, which is written in CPP, because it's quite popular. So you can try to rewrite it to Kotlin Multiplatform, see if it works, and I think it's a good entry point to starting with Kotlin Multiplatform. It's going back to Janek.
So I guess that this would be all for now, and now it's time for Q&A. So throw it at me. Yeah.
So my question is, have you found any way, or have you have any tips how to convince iOS developers to take a part in Kotlin Multiplatform project where the common domain logic is written in Kotlin, not in Swift?
That was actually a huge problem for us, but it wasn't that hard to convince our iOS developers to try Kotlin, because Kotlin is very similar, as I said. But yeah, it might be an issue initially. Like there may be huge backlash on a new project. If you have like a big project and you want to transfer it to Kotlin Multiplatform or try to convince iOS developers to use Kotlin Multiplatform. But you can always start with small parts and just try to convince your iOS developers that it will be better for your project to write the same logic once. And yeah, after a few weeks, it's not that bad for them either.
Actually, we started with like writing native views in iOS, and then after this introduction to Kotlin, iOS developer wanted to change something in this common module because they need some interface or presenter, and they like started to write Kotlin code, and it just
exactly.
works.
Exactly.
Hi, I am an iOS developer.
Hello.
And I wanted to ask about debugging experience on iOS.
It's a great question. Kevin Galligan, the guy I've mentioned 3 times already, he wrote a Kotlin plugin for Xcode, so you can debug, you can edit and debug Kotlin code in Xcode. So it's not that bad.
Okay.
It sees just.
Is the plugin available for?
Yeah, it's
use?
up online. Yeah, it's ready even for the newest beta of Xcode. Yep, I've seen the conversation on Slack that it's ready to go. So the debugging is quite good. Yes?
I have a question regarding your just regular day-to-day work as a multi-platform developer. Do you compile for every single target every time you build your app, or you just choose one target like the JVM and you test that and you just play with it and then compile for native, for instance? Because I've heard that compiling for a native is way slower actually than for the JVM.
It used to be the case. It's not the case anymore. Like for 3 or 4 months now, the same as Intelij IDEA, it's as fast as Android pretty much. You have to compile the framework and then you can use framework in your iOS app, and it's quite fast. So in everyday life, we compile both of those and we try both apps. So, yeah. Yeah.
Thanks for the presentation and highlighting the most important things about this framework. And I have a question about Bluetooth support. Of course, automation. Writing one code for API is obvious in this framework, but is it possible to write one code in native for Bluetooth communication? Because it's very often case when we have to write cross-platform application and implement somehow Bluetooth communication. And is it possible in Kotlin native, as in React native or Flutter, using some libraries?
There are no libraries for this, but you can always write the expect actual thing and write it on the platform. So it's doable. I don't think that I've read about anyone who actually did it, but I think it's doable, yeah. You could do this. Like you can close this logic behind Kotlin Multiplatform, and as Maciej mentioned, you can share it between different projects. So it pretty much ends up as a library for Kotlin Multiplatform with actual implementations on platform sites.
So actually, what we are doing in our application, we're just trying to like close everything behind some kind of interfaces. So if we have problem with, for example, dates, we create our interface in Kotlin and then just use expect actual and implement it on platforms. So same story. You can just create interface and implement like natively a Bluetooth communication.
Yeah, so you just create a multi-platform library. Then you can share it online, and people will be happy. Okay.
So maybe a question regarding asynchronous communication. Basically coroutines you've mentioned that you are using correctly. And so how the interfacing between iOS and coroutines interface from Kotlin looks like?
Right now there is no communication between coroutines and the native platform because it's not allowed. It doesn't work really well. There are some works on this. But right now we just use coroutines for any asynchronous operations on our common site, and then we post results to iOS, and iOS takes care of the results. Like
basically, you have to have all interfaces with callbacks, right?
We use, as I mentioned, we use MVP where the presenter is on the side of common, so all the logic is closed in coroutines, and then the presenter just interfaces with Vue. And so there are no callbacks, but that was our initial approach as well with callbacks. Then we tried some reactive stuff and some features. It's doable, but it's hard. So our approach is just way easier. Okay. Yep.
Did I understand correctly that you are using Ktor for network requests?
Yes.
And what are you using for local?
For there is SQL, the Lite library for Kotlin Multiplatform. Is this what you are asking for?
I'm asking more like, are you, for example, if you have an application that has 3 layers, data domain presentation, if we have a specific repository, usually business logic requires only to have interface just to specific repository interface without without the knowledge that there are actually network requests inside it.
Okay, yeah.
So you have network requests on multi-platform side and database requests on platform side. For each platform you have specific database, isn't it?
Actually, we have implementation for these shared preferences. I mean, we have like shared preferences using actual.
Yeah, but if I understand you correctly, then you can write your database connection just as you would any other library, that's first. And if you want to use SQLite, then it's already made. You
write the implementation with SQL
support.
If you want to connect to some other other database, then yeah.
It supports maybe on iOS and Android, but what about TVs?
Then yes. Then if you want some other database, then you have to write it on your own. Yeah.
Okay, so if you would like, okay, thank you.
Okay. Any other questions?
I have a question about repository structure. So is all the code in one repository? Is it one project and everything is a Gradle module, or how do you structure and share?
Actually have
modules?
5 repositories. We have our common code in one repository, together with the platform-specific implementations. Then we have Android repository, we have iOS repository, we have one repository that you wouldn't need because it's only for our specific case, that contains the project-specific logic, and then we close it all together into one bigger repository so you could download it from GitHub and it could all run together. So if you open it,
sub-repositories?
Yeah, something like this. So just repositories. Yeah, but it's one huge project.
I have a question about when do you need to provide the actual implementation. So let's say you define some expect logic, and then you have Android and iOS moving at different speeds. So let's say Android already implemented the actual part. Does that mean that the iOS need to implement it at the same time, or will their project still work?
The actual and expect are still in common code. So if you remember this, I could look it up. Give me a second. It looks like this. Everything below the artifacts is still common code. So it's responsibility of your common code team to provide the actual and expect implementations, right? So if you write that your common app expects something from the applications, then it will not compile. So your common team has to actually provide the expect. And then you take both expect and actual, you make jar file out of it, and you provide it to actual Android application to consume. So it's like you have to provide it at the time you need it, at the time you write it.
So you can't use it on one platform until you provide support for all the targets that you cover.
You can always just leave it empty or just put some to-do there or some other. Yeah, you can just leave it till you are ready to fill it. We used JS like this for a little while, that we just put some mock implementations of all the expect methods. Okay. Okay, so I guess that would be all. and join the Slack if you are interested. And yeah, I hope you enjoy. Thank you.